This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. On August 1st, NASA's Jet Propulsion Laboratory picked up a signal from Voyager 2 using the agency's Deep Space Network. Voyager 2's carrier signal, called its heartbeat, confirms that the spacecraft is still broadcasting. JPL's statement added, "Engineers will now try to send Voyager 2 a command to point itself back at Earth. If that does not work, we'll have to wait until October, when the spacecraft's onboard software automatically tells it to reset its direction." The Voyager 2 spacecraft, which is about 12.4 billion miles or 19.9 billion kilometers from Earth, lost contact with our planet after an error in a set of planned commands accidentally moved Voyager 2's antenna 2 degrees away from the Earth, leaving it unable to receive commands or transmit data back to Earth. Luckily, Voyager 2's programming has backups enabled that allow the spacecraft to automatically reset its orientation a few times a year in case of troubles like this. The next such reset is scheduled for October of this year. Here is astrophysicist Claire Kenyon on ABC News Australia to explain a bit more about the situation.
They do routinely send commands to Voyager, Voyager 1 and Voyager 2. This one's Voyager 2. They do routinely send packets of information, and unfortunately, in this little packet of information they sent, they had a little error. And the little error said, please rotate yourself 2 degrees away from where your antenna is pointing at Earth. And 2 degrees doesn't sound like a lot, right? But when you are almost 20 billion kilometres away, and if you're any good at trigonometry, and if you're a maths teacher, you get your year 9s to do this, you can work out that makes a pretty big difference over that space.
So look, they've picked up a heartbeat. What does this tell us about the options they have to try and reconnect? Well,
the great thing is, so I've heard it described as billions of times weaker than the power coming from your wristwatch. So we're talking really, really weak signals, but they've managed to pick it up using, we've got these antennas in this deep space network, and we've got some in US in California, some in Madrid, and we've actually got one in Canberra in Tidbinbilla, say that 10 times quickly, and this antenna actually is designed to pick up these really weak signals. So they sort of heard this very weak signal from Voyager 2. This means that Voyager is still broadcasting. It's still, well, relatively healthy, I suppose. It's just that it's not quite pointing where it should be. So the hope is here, now that we've actually gone, yes, we found it, yay. The hope is maybe to try and send some packets of information to get it to reorient. Now, I don't know, 160 bytes per second. It's not a lot of information. It's very, very slow, and it takes over 18 hours to get there. So it's not sort of something I'd be waiting up, holding my breath for in the next hour or so, Bev, given that they only sort of found out about this morning, 3:30, I think.
Yeah. So if those attempts are not successful, what's next?
Well, luckily, NASA's design people, NASA and co, built in contingencies for this exact thing. Well, probably not this exact thing, but some of these types of things. And basically what the Voyager spacecraft do is they use the position of the sun and a star called Canopus, which is a very, very bright star, so quite reliable. And periodically through the year, it actually uses those two things in the sky to actually reorient itself. So the next one of those is actually due in October 15, which is a little bit serendipitous because it's quite close. So we may only have to wait another 2 and a bit months to have it automatically do it for itself, fingers crossed. Voyager program was and is absolutely incredible. First of all, they were launched in 1977. They are still sending us back information well and truly after their life frame. They were not designed to actually go for this long. And so the very first amazing thing is that they've survived these conditions out in space for some 3 or 4 times their actual intended working life. So that's one thing. But yeah, they were first of all destined to go to the planets. So Voyager 1 went to Jupiter and Saturn. Voyager 2 actually went Jupiter, Saturn, and then on to Uranus and Neptune. And it looked at the moons of Jupiter and Saturn, but Voyager 2 actually is still the only spacecraft that's been out to Uranus and Neptune. Voyager 2 found moons out there, so they found some, I think, 10 or 11 moons around Uranus, and then a couple of rings and 4 rings around Neptune, and some moons as well. So it's sort of incredible what it's achieved over the last 40 years. And now both of these spacecraft have actually sort of left the reach of our sun. So particles are streaming out from our sun all the time, and eventually they get to this sort of shock area and they sort of don't go any further. And once a spacecraft has gone beyond that boundary, which both of the Voyagers have, they're in interstellar space. So sending us information from a place that we've never ever been before, and in fact probably, I certainly won't be there ever.
The Voyager 2 missions are slowly losing power from their nuclear radioisotope generators, but engineers have made alterations over the years to preserve the systems where possible while still allowing the power supplies to last longer. In April 2023, NASA announced that Voyager 2 will postpone a planned instrument shutdown by at least 3 years, continuing to gather valuable deep space data until at least 2026. Voyager project scientist Linda Spilkner at Jet Propulsion Laboratory in Southern California said, "We are definitely interested in keeping as many science instruments operating as long as possible." You know, it still amazes me that the Voyagers are still operating after over 45 years. So keep up the good and amazing work. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.